Hi, this is P. Antony Vimal, Assistant Professor, St. Xavier's Catholic College of Engineering. In this particular video, we are going to see about the basics of dams. Dam is a solid structural barrier constructed across river to hold water, flowing water. And the purpose of constructing a river is listed below. First, it to produce hydroelectricity and to supply water to the agricultural field and water for domestic consumption and to supply water during drought period and regulate the water during flood and for navigational facility and some other development works. This particular video portrays the various structural components of a dam. First, upstream, downstream, heel, toe, gallery, sluice way, spillway, maximum water level, normal water level. I will explain you the each dam in the upcoming slides. Contact of dam with ground on the upstream and downstream are respectively called heel and toe. Next, abutment. Abutment is nothing but the sides of the valley on which the entire structure rests. Gallery. Gallery is a small room constructed within the dam for doing checking operations. Next, diversion tunnel. Before constructing a dam, the existing water is diverted by constructing diversion tunnel. Spillway. Actually, it is there on the top of the reservoir to release excess water of reservoir to the downstream side. Next, sluice way. It is an opening in the dam near the ground level to remove the silt accumulation in the reservoir side over a long duration of time. Next, we are going to see about the types of dam. First, it is gravity dam. Gravity dam depends entirely on its own weight. It is made of concrete. Here the total weight acts vertically downward. Here the entire load is transmitted over the small area of the foundation. Therefore, the soil pressure will be maximum. Therefore, the underlying soil should be of maximum safe-bearing capacity. Therefore, gravity dam is normally preferred over the soil medium of rocky stratum. If the underlying soil is of rocky stratum, only then a gravity dam is preferred. Bagranangal Dam is a wonderful example for gravity dam. It is the highest in Asia and second highest in the world. Actually, it is constructed across Satluj River in Himachal Pradesh. The construction work started in the year 1948 and completed in the year 1963. Its height is 740 feet, and when compared to the height of Qutub Minar, it is 3 times higher. The length of the Bagranangal Dam is 1,700 feet, and its width at the base and top are respectively 625 feet and 30 feet. And this slide shows the side view and top view of the Bagranangal Dam. Next, we are going to see about Buttress Dam. Actually, if the sloping deck of the gravity dam is supported by a series of buttresses, it is called Buttress Dam. If buttress is provided, the size dimensions of the gravity dam can be reduced, and so the amount of construction materials required will be reduced significantly when compared to gravity dam. Moreover, buttress dam may be preferred if the underlying soil is. Next, we are going to see about arch dam. The name itself expresses what it is. This type of dam is made of either concrete or masonry. It is curved, convex, upstream in plan. This shapes help to transmit the major part of the water load to the abutment. Arch dam is normally constructed across river of narrow and deep. A wonderful example for arch dam is Idiki Dam, which is located in Kerala, India. Next, we are going to see about earth dam. Earthen dam is made of earth and it is trapezoidal in shape. And if the underlying soil is very weak and so low bearing capacity, earthen dam is preferred. When compared to the base width, its height is very less. When we do design a dam, 6 key parameters are there to be kept in mind, and they are hydrological factors, geological conditions, structural dimensions, material property, reservoir capacity, and spillway design. Under hydrological factors, importance are given to flood discharge, catchment area, rainfall intensity. Geological conditions deals with foundation rock strength, that is the safe bearing capacity of the soil, seepage control, and earthquake potential, that is the possibility of the occurrence of earthquake. Structural dimensions deals with height, top and bottom width, freeboard, and the side slope. Next, material properties. Material properties mean what material the dam is made of, and the compaction, permeability, cohesions are the important properties of underlying soil. Reservoir capacity, importance are given here to storage volume, dead and live storage, filtration allowance. Spillway design. Spillway is nothing but a component used for releasing excess water to the downstream side, and Ogi, chute, siphon are the important types of spillway. During design a dam, 6 stability checks have to be done very carefully, and they are overturning stability, sliding stability, foundation safety, seepage control, earthquake stability, and uplift pressure. Overturning stability. Overturning stability. Here, overturning moment is due to the water pressure. The overturning moment is resisted by the resisting moment. Here, the resisting moment is mainly due to the self weight of the dam. Next, sliding stability. Here, the lateral force is mainly due to the water. The lateral load lead to the sliding of the dam. The lateral load is resisted by the frictional force induced between the dam and the underlying soil. Next, foundation safety. Here, the soil pressure due to the vertical load should be less than the safe bearing capacity of the soil. Next, seepage control. Seepage can be controlled by providing proper drainage and cutoff measures. Next, earthquake stability. In order to make dam earthquake resistant, dynamic analysis under seismic loads have to be done. Indian codes IS 1893 and IS 6512 provides important specifications to be carried out for doing dynamic analysis under seismic loads. Next, uplift pressure. Uplift pressure can be controlled by providing drainage galleries and foundation grouting. Before the commencement of any project, its short-term and long-term implications have to be analyzed very carefully. If the implications are very severe, the project should be put off. When constructing a dam, the environmental impacts induced are summarized below. It alters river ecosystems and aquatic life, submergence of forest, wildlife habitats and settlements, disruption of sediment transport downstream, water temperature and quality changes, and social impacts. It leads to the relocation of tribal people staying there over a long period of time, and so loss of cultural heritage. The site selected for constructing a dam should fulfill the following conditions. First, the foundation geology should be stable with minimal fault lines. That is, the site selected should not be a earthquake prone region. And if we want to construct a gravity or arch dam, the valley should be of narrow with high abutments. And the site selected should be in such a way that the construction and maintenance works are carried out in the easiest way, and the construction materials are available easily from the site selected. Finally, the settlement and environmental impact should be minimum. Finally, instrumentation and monitoring in dam. Actually, dams are equipped with certain instruments for doing monitoring the safety of the dam periodically. And the instruments are listed below. Piezometers, it measures the pore water pressure. Inclinometers, it tracks internal deformations, and certain instruments are there to measure the seepage. It is identified by the leakage and flow through the body. Extensometers, it monitor displacement across joints. And finally, real-time data logging for safety. Thank you.